Welcome. Today we're going to solve a complex integral involving a square root in the denominator. Let's look at our integral. The integral of dx divided by the square root of 5 plus 2x plus x squared. The first step to solving this integral is to complete the square for the expression under the square root. Let's rewrite 5 plus 2x plus x squared as x squared plus 2x plus 5. Now, to complete the square, we take half of the coefficient of x, which is 1, square it, and add and subtract it from the expression. So we get x squared plus 2x plus 1 minus 1 plus 5, which simplifies to quantity x plus 1 squared plus 4. Our integral is now the integral of dx divided by the square root of quantity x plus 1 squared plus 4. This is a standard form that leads to the inverse hyperbolic sine function. The standard form is the integral of dx over the square root of x squared plus a squared equals the inverse hyperbolic sine of x over a plus c. Let's make a substitution. Let u equal x plus 1. So do equals dx. Then our integral becomes the integral of do over the square root of u squared plus 4. Using our standard form with the equals 2, we get the inverse hyperbolic sine of u over 2 plus c. Now we substitute back x plus 1 for u, giving us the inverse hyperbolic sine of quantity x plus 1 over 2 plus c. Finally, we can express this using logarithms. The inverse hyperbolic sine of z equals the natural log of z plus the square root of z squared plus 1. Therefore, our final answer is the natural log of quantity x plus 1 over 2 plus the square root of quantity x plus 1 over 2 squared plus 1 plus c. And that completes our solution.